In this video, I'll explain what is convergent, divergent, and oscillatory sequence. So, given sequence, nth term is denoted like this an, where n belongs to n, natural numbers, means n equal to 1, 2, 3, and so on. A1 means first term of the sequence, A2 second term, A3 third term, and so on. Now, I will define convergence, divergence, and oscillatory sequence using limiting value of the nth term. If limit of an as n tends to infinity, if you get it as unique and finite value, then we say that the given sequence an is convergent. For example, if you consider this sequence, that is sequence 1 by n, where n belongs to n, then when you go on giving the value for n, we will get 1, 1 by 2, 1 by 3, 1 by 4, and so on. So, this is the given sequence. Now, to check whether this sequence converges to some value or not, we have to find out limiting value of nth term, which is n by 1 by n as n tends to infinity. So apply the limit, n is infinity. So 1 by infinity equal to 0. This is a single value as well as a finite value. Hence, this sequence is convergent and it converges to 0. Converges to 0. So, this is how we check the convergence of the given sequence by finding the limit of the nth term of the sequence. Now, for divergent sequence, limit of an as n tends to infinity is either plus infinity or you can get minus infinity. So, in that case, we say that the given sequence is divergent. For example, consider the sequence n, that is equal to, when you go on giving the value for n, you'll get 1 comma 2 comma 3 4 and so on. This is the easiest and simple sequence. So now find out limit n tends to infinity, nth term is n, apply the limit, we'll get infinity, it goes to plus infinity, therefore this sequence is divergent. But see here in this case, when you go on giving the value for n, we'll get minus 1, minus 2, minus 3, and so on. So find out the limit of nth term of the sequence, that is minus n. Apply the limit, we'll get minus infinity. You can get either plus infinity or minus infinity. In any of the case, it is divergent. So therefore, in this case is also the given sequence is divergent. Now, for oscillatory sequence, there are two categories. The sequence may oscillate finitely or the sequence may oscillate infinitely. Oscillatory sequence means you have to find out the limiting value of the nth term. You may get it as finite, but it is not unique. You may get more than one value for the limiting value of the nth term. In that case, we say that the given sequence oscillates finitely. Say, for example, consider this sequence minus 1 to the power n. N belongs to n. Go on giving the values, we'll get 1 minus 1, first term n equal to 1, second term minus 1 whole square is 1, minus 1 1, minus 1 1, and so on. Just by looking at the terms of the sequence, you can say that it is neither convergent nor divergent, therefore it is oscillatory and it oscillates finitely between minus 1 and 1, because once it is minus 1, next term is 1, again it is minus 1 and it is 1. So when you are checking it through the limiting value of the nth term, what you can do is you can find out a to n and limit of a to n plus 1. Whenever you have minus 1 to the power some value, always go with this way. Find a to n, that is for even, and for a to n plus 1 for odd values as n tends to infinity. In both the cases, if you get same value, then the sequence is convergent. Let us check for this. A to n is limit n tends to infinity minus 1 to the power 2n. So minus 1 to the power 2n is always positive. So this gives you the value 1. But in this case, minus 1 to the power 2n plus 1, this is odd, this gives you the value minus 1. That is what mentioned here. The value is finite, but it is not unique. In this case it is 1, in this case it is -1. Both are not giving you the same value for the limit. Hence this sequence oscillates finitely. Oscillates infinitely means limiting value of the nth term as n tends to infinity is infinite, but that is also not unique. Means you won't get the single value for the infinity. It might be plus infinity for one set of values and minus infinity for another set. See, for example, here consider this example. So when you give the values for n equal to n, we'll get -1, then 2, then -3, 4, -5, 6, and so on. So you have here even positive numbers and odd negative numbers. So limit as n tends to infinity a to n, and limit as n tends to infinity a to n plus 1 you have to find out. So a to n means all even means -1 to the power 2n into 2n. So this gives you n tends to infinity. -1 power 2n is positive, then it is 2n. So apply the limit, it goes to plus infinity. Similarly, here -1 to the power 2n plus 1 is -1 into 2n plus 1. Apply the limit, this gives you minus infinity. That means the limit is infinite, but it is not unique. Once it is plus infinity, once it is minus infinity. Hence, this is an oscillatory sequence and it oscillates infinitely. Therefore, whenever a sequence with nth term is given, for to check convergence, divergence, or oscillatory, you always have to find out the limit of nth term of the sequence. If it is unique and finite, it is convergent. If it is either plus infinity or minus infinity, it is divergent. If it is neither convergent nor divergent, then it must be oscillatory. If it oscillates between a finite value, it is oscillates finitely. If it oscillates between infinite values, then it is called as oscillates infinitely. Hope you understood this concept. Thank you for watching.